So it seems pretty straightforward, or pretty obvious that we're going to be using the product rule. So let's remind ourselves of the product rule here. What is the derivative of some function f times some function g? You hopefully remember that's f prime g plus f g prime. So how are we going to use this in integrals? Well, let's try just integrating it. So we'll have the integral of f times g prime. That would be the integral of f prime g plus the integral of fg prime. I'm kind of being lazy or sloppy about the whole dx thing. We'll come back to that. What is the integral of the prime of something? What's the antiderivative of the derivative? That should be the original function, right? So we'll get f times g on this side. And then let's just rewrite this. Now we're going to do something unintuitive. Let's take this and subtract it from both sides to get just this thing all by itself. Because if we want to have a rule for integrating stuff, it would be nice if we had just one integral on one side of the equation, right? So we're going to take this and subtract it from both sides. So it'll move over here with a minus, so we'll get f times g minus integral of f prime g equals, and then that's missing from this side, and now we'll have the integral of fg prime. So if you had something that had an integral of something times the derivative of something else, you could use this formula to rewrite that integral. Now we're going to introduce new notation. We're going to say f is now going to be called u, and g is now going to be called v. So we're going to be using u's and v's. That way we free up the original f for like the full integrand, not just part of the integrand. So let's rewrite this. F becomes u, g becomes v, minus the integral. And now I have to reorder these. G is v, so I'm going to call that v, and f prime would be u prime, which I'm going to call du, and that's the integral of u times dv. All right, so if you have an integral of u times dv, you can rewrite it this way. So let's write that down as the integration by parts formula. Integral of u dv equals integral sorry, not that one, uv minus integral of v du. Do you see anything here that you might accidentally forget in the midst of a problem? That minus sign right there, lots of people accidentally put a plus sign right there because they're kind of used to the product rule, but this is kind of the opposite of the product rule, so it kind of makes sense to have a minus there. So let's try applying this to the problem we had before, integral of x e to the x dx. What do you choose for u, and what do you choose for dv? So that's what we have to do. We have to segment whatever integral we have into a u and a dv. So the guidance for how to segment the integrand into what's u and what's dv, we'll get to that in a sec. For now, let me just say that u is going to be x, and this whole thing is going to be dv. So now that we have chosen a u and a dv, we need to think about what is v, because I need that in this formula, and what is du, because I'm going to need that. So it's nice to make a little table. So say u equals x, and then what is du? Well, it's just dx, right? We're taking the derivative. So that part is the same as u substitution. So from here to here, we're taking the derivative. And then here, let's write our dv. It's e to the x dx. Notice I'm keeping that dx there. The dx isn't just sitting here in the integral. It is part of dv. And then how do I get v from dv? I take the antiderivative, what's the antiderivative of e to the x? It's e to the x. And the dx, well, what happens when we take antiderivatives? We don't write the dx anymore. So this is the table format I like. Some people, when they teach it, especially if you've had Calc 2 before, this might be an issue. They put both u and v on the top row where they don't know v yet. They put du and dv on the bottom row, and then when they take the antiderivative, they go back up and write something here for v. Either of those is fine as long as you're consistent. So let's write our new formula here. Let's write the integration by parts formula. uv minus integral of v du. What is u? U is x. What is v? E to the x minus the integral, what is v? E to the x. And what is du? It's dx. So we took u, changed it to x, v, changed it to e to the x according to what we had written here, minus the integral of v, which is e to the x from here, and du, which is dx, like there. So integration by parts, just like the u substitution, doesn't solve the integral for you. It just gives you a different integral that's hopefully easier to do. So let's actually do this integral now. What is integral? What is x e to the x? Well, we could just copy that because that's not in the integral. And then what's the integral of e to the x? It's e to the x plus c. You don't have to worry about, like, is the plus c in parentheses or not. In general, whatever you get from this should be in parentheses, but it doesn't really matter whether the plus c is in the parentheses or outside. All right, so what's the next step here? We should check it. Take the derivative by hand. Well, we actually just did that in the previous video. It all worked out. Notice this is what we got in the previous video. We could do the checking in Desmos. That's not a bad idea. Maybe we'll go do that. All right, here we are. Let's say f of x equals x e to the x. That's what we started with. This function isn't actually all that useful. More useful would be x e to the negative x, which is a surge curve. So we'll get to doing that. Let's put in our by hand antiderivative, which was x e to the x minus e to the x. And then we'll say capital F prime of x. And that should exactly overlap the original function here. I'm going to put that in dots and change its color so it contrasts with the red. So if we got the antiderivative right, then its derivative should exactly match the original integrand function, and that looks like it's working pretty well. Someone was asking me, how does this work with t's? Let's go back and put t's here, and it works almost exactly the same way. So I'm replacing all those with t's. So it all looks the same. Putting a letter here just tells Desmos, whenever you see that letter in the rest of the formula, it's whatever comes from whatever the user gives you here. And then it just, if you're defining a function, it figures you want that graphed along the x-axis, regardless of what this letter is. The tricky part comes when you say capital F prime. If you just say t here, it thinks you want a value. It doesn't realize that we often use t as the x-axis. So it wants to make a slider there, which we don't want. So we have to put an x here if we're asking it to evaluate some function and graph it as a function of x. So I'll do the same thing as before. So that's one place you need to be a little bit careful with t's and x's. Desmos won't understand if you put a t here. All right, so our graph checked out on when we took the derivative of our antiderivative. In the next video, we'll talk about some hints for choosing u's and v's and other stuff.